So 13.1 focused on graphing inequalities on a number line. Now we're going to go to a coordinate plane. There are going to be two number lines here. So a coordinate plane is a collection of points identified by two perpendicular number lines. And that's what this diagram right here is. It's a coordinate plane. And I'm going to label it as we go. The x-axis is the horizontal number line. Sorry, string blew onto my iPad. Horizontal means left and right, flat. So the x-axis is this guy right here in the middle. This black line through the middle of the diagram. That is the x-axis. You'll notice there are no numbers listed on the number line. Each of those gray lines is one unit, for lack of a better term. So the first gray line to the right of the middle is 1. As you go left from the middle, we have negative numbers. So this is the positive side of the x-axis, and this is the negative side of the x-axis. The y-axis is the vertical number line. So it's this guy that goes up and down through the middle. And just like the x-axis, there's a positive and a negative part. The positive part is up, and the negative part is down. The origin is where the two axes meet. So that point right in the middle is called the origin. A quadrant is one of 4 parts the axes divide the plane into. Okay, and I think we can see pretty easily, I hope. There's one part. Here's a second part. Over down here is the third part. And on the side here is the fourth part. Each of these are called quadrants. Quad meaning 4. They have names. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. What's going to mess with you is those names are written using Roman numerals. So this is Quadrant 1, upper right, where everything's positive. Quadrant 2 is the upper left, where the y-axis is positive and the x-axis is negative. Quadrant 3 is bottom left, where everything is negative. And quadrant 4 is bottom right, where the x numbers are positive and the y numbers are negative. What you really need to remember for quadrants is that the upper right is quadrant 1, and you go counterclockwise. So instead of going around the way you would read a clock, you go backwards. 1, 2, 3, 4, backwards from top right. And last, an ordered pair is a set of numbers in the form x, comma, y, that's all in parentheses. The parentheses are part of how we know we're talking about an ordered pair. You must put ordered pairs in parentheses to receive full credit. Every year on the Chapter 13 test, 1 or 2 students will write the ordered pairs but not write down a single set of parentheses. You will lose points if you do that. So it's an ordered pair, it's in parentheses, it's x, comma, y, but those will actually be numbers. The first number, the x value, tells you how far left or right to go from the origin. That's because the x-axis goes left and right. Negative numbers go left, positive numbers go right. The y number, the second number, tells us how far up or down to go. Positive numbers going up, negative numbers going down. So now we're going to identify the ordered pair for these points. So these are points A, B, D, E, and F. There is no point C. And notice as points, these are just capital letters. Okay, lowercase letters are used in equations and inequalities. Capital letters are used for points. So to identify the ordered pair, to tell where each of these things live, what we need to do is start at the origin, the very center point, and count. So remember, all ordered pairs look like X, comma, Y. X is how far left or right we have to go. Y is how far up or down we have to go. So how do I get from the middle? How do I get from here up to A? Well, I have to go right 2 places. Then I can turn and go straight up 1, 2, 3, 4, 5, 6, 7 places. I have to go right 2, up 7. That means the ordered pair for A is 2, 7. Both numbers are positive because I went right, which is positive, then up, which is positive. You cannot travel diagonally. You can only go left or right, then up or down. It's kind of like a claw game. At least when I used to play claw games, you had to move the joystick left or right first, then you would move it up, and you couldn't move left or right again after that. So you've got to come left or right first, then up or down. So how do we get from the center, which is where we always start, up here to B? Well, now I'm going to go left 1, 2, 3, 4 places? Yeah, just 4 places. I'm going to turn then and go up 1, 2, 3, 4, 5, 6 places. I'm going left 4, left is negative, up 6, up is positive. So B lives at -4, 6. There is no C. So to get from the center to D, we have to go left 1, 2, 3, turn and go down 1, 2, 3. That means D is at -3 because we went left, and -3 again because we went down. Left and down will give us negative, negative. E doesn't go left or right at all. So its first number will be 0 to indicate we didn't move left or right at all. We did go up 1, 2 places, so the ordered pair for E is 0, 2. And F, we have to, from the middle, go right 7 steps before we can turn and drop, go down 5 steps. So right is positive, so that's a 7, positive 7. And then we go down, so that's a negative, so down 5. What you may have noticed as we did this is that everything in quadrant 1 is a positive, positive. Everything in quadrant 2 is negative, positive. Everything in quadrant 3 is negative, negative. And everything in quadrant 4 is positive, negative. Okay, that could be useful to know. In addition to telling me where points live, I'm going to ask you to plot ordered pairs on planes. And I have paper that has coordinate planes on it, so you will get a sheet of that to do your problems on. It'll also be available in the classroom as a PDF file, so if you need more at any time, you can print it yourself, if you can't grab it in the classroom. So plot on the ordered plane. Plot the ordered pairs on the plane. A lives at 3, 4. Those are both positive, so that means right 3, up 4. So right 3 up 4, so from the middle, from the very middle, I'm going to go right 1, 2, 3, and I'm going to go up 1, 2, 3, 4. That's roughly there. And that is point A. If I'm told the name of a point, I should include it when I graph it. B lives at negative 2, 7. That's left 2, up 7. So left 2, up 1, 2, 3, 4, 5, 6, 7. Roughly there. And if you don't think that's where B belongs, did you remember to go back to the origin before you started counting? Remember, we always start from the origin. Point C now lives at negative 3, negative 4, which is left 3 and down 4. So left 3, 1, 2, 3, turn and go down 1, 2, 3, 4. That point's a little bit low, but good enough. That is C. D lives at 3, negative 5. So 3, negative 5 means right 3 and down 5. So right 1, 2, 3, turn and go down 1, 2, 3, 4, 5. That is nowhere near. Pardon me. Let me try plotting that again. Right 1, 2, 3, down 1, 2, 3, 4, 5. That's better. It can be kind of difficult sometimes on an iPad to get my points to land exactly where I'd like them. The point E lives at 0, 3. When the first number is 0, that means don't move left or right. From the middle, just go up 3. And again, I can do better than that, I think. Hey, that's a lot better. That is E. And F is at 4, 0. So 4 says go right 1, 2, 3, 4 places, but the second number being 0 says don't go up or down at all. Yeah, I can probably do a little better than that. Yeah, maybe I can't do a little better than that. There's F. So it's just remembering when to go right, when to go left, and counting. Last example, from what we graphed above, find the distance between points A and D. A and D are directly up and down from each other, so we can count. Could also do it if they were directly left and right of one another. You cannot do distance diagonally yet. You will learn how to in the future. So for this, to get from A to D, we're just going to count, and it doesn't matter where you start, we're just counting the number of steps. I'm going to go from A to D. So this is going 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know exactly what we're measuring in, so we just use the generic word units. There are 9 units, 9 steps between A and D. Remember, when you're counting these things, you don't start 1 at A. 1 is your first step down from A.